Newton's second law of motion is useful in describing the relationship between velocity, force, mass, and time. By manipulating Newton's second law, one can even predict physical quantities of a system into the future, such as velocity and position. Note that when no net force is applied, the velocity will remain constant. In order to demonstrate this law, I recorded a roll of masking tape rolling across the floor, and then I used a program called Tracker to find the position in relation to time. Furthermore, I manipulated a code on VPython to mimic the qualities of my system, and I created a computational model of the position of the masking tape as a function of time. This graph displays the predictions of VPython in green in comparison to the tracker data in blue. As shown in this graph, the computational model closely mirrors the true position. This is because I chose to use a very simple system where I can control which forces were exerted on the system to an extent. It is important to note that because, as implied by Newton's second law, for a velocity to remain constant, the net force must be equivalent to zero. Therefore, even though it is impossible for me to predict all of the pushes and pulls acting on my system, I could just make the assumption that the net force was equal to zero, which came into play as I made my computational model. Another important decision I had to make was the placement of my axes. I chose to have my model move from the origin into the positive x direction. However, if I had switched my axes, my data would merely be shown with a negative slope. The magnitude of the movement, however, would remain the same. This concludes the beginner's look of constant velocity in relation to Newton's second law of motion. Until next time!